Hello, welcome to our introduction to one-dimensional kinematics. Now you've already done a couple of labs studying the motion of objects, particularly a radio-controlled car and some balls rolling down a ramp. And the analysis you did was based on graphing. Now this graphical analysis is the first thing we want to talk about. We want to talk about what we've learned from that, and then we're going to use that as a springboard to study the four kinematic equations that will be very useful in our beginning studies of mechanics. All right, first of all, let's talk about a change in position of an object. That would be its displacement. We went out on the track first and used a radio controlled car to actually measure the change of position of the car over time to get a rate that we determined was velocity. Now we said that a simple formula for velocity is distance over time, delta x over delta t. But we pointed out that that's really an average time, and so that's a velocity over a time interval. But you also remember that you first discovered that by calculating the slope of a position versus time graph. If we want to find the velocity at a given moment, that would be instantaneous velocity. An instant, remember, is kind of an infinitely small amount of time. So that would be delta x over delta t as t starts to approach zero. If you've had calculus, you're probably more familiar with it written in this format. The limit as t approaches zero, or dx over dt, the derivative formula. What that's doing graphically is actually calculating the slope of a tangent to a curve on a position versus time graph. We also looked at changes in velocity, and we did that by calculating the slope of a velocity time graph and found that to be the acceleration of an object. A simple formula for acceleration is just change in velocity over time required for the change. But again, that's an average. Now, it's the slope, as we said, of a velocity versus time graph, but on that same velocity versus time graph, we can also calculate the area under the curve. That would give us the displacement of the object during that time period. If we wanted to find an instantaneous acceleration, that would be pretty much the same process as an instantaneous velocity, just on a different graph. The formula equals v over t would work if t was approaching zero. So we get those same old calculus style formulas again. This time what you probably learned is a second derivative. And again, what you're really doing is finding the slope of a tangent to a curve, just this time on a velocity time graph. Just as we can study changes in position or changes in velocity, we can also talk about changes in acceleration. And a rate of change of acceleration is called jerk. You feel this all the time whenever you're riding in a car and the car is speeding up and changing gears. Every time the gear is changed, the rate of acceleration of the car changes a little bit. It's easy to remember what it's called because if you ride with somebody that's not good at shifting gears, you get jerked around a lot. This is the slope on an acceleration versus time graph. Now on that same graph, we can calculate the area under the curve, and that would give us the change in velocity of the object that we're graphing.